Let's dive right into this explainer. Today, we're demystifying the continuous 8-stage loop that modern engineering teams use to build and ship software safely. If you've ever wondered how tech giants manage to push out updates multiple times a day without crashing their entire platforms, well, you're in exactly the right place. To keep things beginner-friendly, we've broken our journey down into 6 quick parts. Welcome to the DevOps loop. Stages 1 and 2, plan and code. Stages 3 and 4, build and test. Stages 5 and 6, release and deploy. Stages 7 and 8, operate and monitor. And finally, we'll look at the future of DevOps. Welcome to the DevOps loop. Let's start by looking at why the tech industry absolutely needed a cure for the traditional, chaotic way of making software. The contrast here is literally night and day. Back in the old waterfall days, developers would write their code in total isolation and then basically chuck it over a metaphorical brick wall to the operations team to deploy. It was a mess. You had isolated teams, massively delayed manual releases, and the absolute worst part, huge deployment downtime. The DevOps loop cures all of that by merging dev and ops into this beautiful, automated, continuous assembly line where the ultimate goal is zero downtime. Section 2, Stages 1 and 2, Plan and Code. To make this super concrete, let's follow a real-world example. Imagine we're building a brand new payments feature for a giant e-commerce site like Amazon. So, this is where it all kicks off. In the plan stage, product owners and system architects map out exactly what this new payments button needs to do. They figure out the look, the feel, the high and low level requirements. Then, jumping right into the code stage, the developers take those blueprints and start typing out the actual application logic. Now, obviously, this doesn't happen in a vacuum. Project managers are tracking all this work in agile sprints using tools like Jira boards, while the devs are constantly committing their code to version control systems, think GitHub or Azure repos. That ensures every single keystroke is tracked and versioned safely. Section 3, Stages 3 and 4, Build and Test. The code is written and saved, so we're moving right along the assembly line. So here's the thing, raw code isn't actually very useful on its own. In the build stage, we package that raw code up into a runnable artifact, usually a Docker container these days. Once it's built, boom, straight into the test stage. Here, quality engineers use automated testing to hammer the code, making absolutely sure our new payments button isn't going to break the rest of the existing application. What's genuinely mind-blowing here is the continuous integration, or CI, flow. Nobody is sitting there manually clicking compile or running these tests one by one. The second a developer commits their code, a CI orchestrator automatically triggers the build and runs all the validations. It is completely hands-off. To pull this off, teams rely on tools like Maven to compile the code and Docker to containerize it. And for testing, security scanners and static analysis tools like SonarQube and Snake automatically jump in, scouring the code for bugs or vulnerabilities before it goes a single step further. Section 4, Stages 5 and 6, Release and Deploy. Our payments button works perfectly in testing, so let's shift over to the continuous deployment side of the loop. Now this brings up a massive question. If we update a colossal app like Amazon, aren't millions of users going to experience an outage while we restart the servers? If you remember those old waterfall days, the answer was a painful yes. But not with DevOps. The release stage basically stamps a stable, official version of our payments code, declaring it ready for the public. Then, the deploy stage pushes it to the live production environment. And the real secret sauce here? Using zero downtime deployment strategies. To hit that zero downtime, we've got some incredible tricks up our sleeve. We could use a rolling update, which incrementally swaps out old instances, maybe 25% at a time. Or check this out, a canary deployment. This is super powerful. We route just 10% of live user traffic to the new button. If it crashes, only a tiny fraction of users are affected, and we can roll it right back instantly. And then there's blue/green deployment, which switches traffic instantly between 2 identical environments. Safest route for sure, but it does cost double the infrastructure. Behind the curtain, heavy lifters like Jenkins or AWS Code Pipeline orchestrate this entire release flow. Meanwhile, container platforms like Kubernetes, often teamed up with tools like Argo CD, handle the actual physical deployment to the servers using those exact strategies we just talked about. Section 5, Stages 7 and 8, Operate and Monitor. The feature is live! Users are clicking our new payments button, but guess what? The loop isn't done. You can't just push to production and walk away, right? Operating means actively managing the live infrastructure and handling any incidents that pop up. Monitoring is the watcher. It constantly tracks the health of our new payment service in real time, hunting for memory leaks, errors, or any sluggishness. Here is exactly why monitoring is an absolute game changer. Say the CPU usage on our new servers suddenly spikes to 80%. A monitor catches that and triggers an alert instantly. This means the team or even an automated script can spin up more resources before it hits 100% and crashes the servers. For these final stages, teams usually rely on ServiceNow to track IT incidents. And for monitoring, the absolute gold standard right now is Prometheus paired with Grafana. Prometheus scrapes the raw server data, and Grafana magically turns all that dense information into beautiful, easy-to-read dashboards. Section 6, the future of DevOps. We've seen the 8-stage loop, but where is this automated assembly line heading next? Let's talk about the cutting edge, AIOps, or artificial intelligence for IT operations. Standard monitoring is totally reactive, right? It tells you after the CPU hits 80%. AIOps is predictive. It feeds massive amounts of observability data into machine learning models to predict a server failure literally days before it even happens. Tools like Dynatrace's Davis or Manage Engine Zia are doing this right now. If your e-commerce site has historical trend data, the AI doesn't just wait to alert you when traffic spikes. It actually predicts that tomorrow's order volumes will jump to 63, and it can automatically scale up your server capacity a full day in advance. Zero human intervention required. Which leaves us with a truly fascinating question to close out this explainer. As AIOps agents gain the ability to predict anomalies, write a fix, and deploy it through the pipeline completely on their own, how long until the DevOps lifecycle doesn't need humans at the wheel at all? It's pretty wild to think about. Thanks for joining me on this journey, and I really hope this gave you a crystal clear view of how modern software is actually built.